shall we?
Social distancing, right?
Yep.
Yeah, okay. Go ahead.
All right. Today we're talking about Rite Screen. I'm Andrew Liu.
I'm Dani, Filipi.
I'm Trevor.
And today's agenda, we're going to briefly talk about what Rite Screen is making, and we're going to discuss the current state, screening process and table, and make recommendations and then conclusions. Introduction, we're going to briefly talk about the company background, statement of work, and the constraints. Rite Screen is an outsourcing manufacturing company for windows and screen. The company has been running for 70 years. There are 7 plants located across the U.S. Each plant has its own windows and screen product. And the Rite Screen we're going to talk about is the Fargo location. They produce 21 truckloads of windows and door screens per week. And their main subsidiary is Marvin Windows and Doors located in Fargo, Grafton, and Warlord. They have 15 different window screen options to match the window type depending on the customer's needs. And Rite Screen also builds its own custom windows and door screens. So for our statement of work, what we're doing is analyzing all current 6 window assembly cells and come up with a new ergonomic screening table and increase efficiencies. Some constraints that we have we face are a delay project start, which took us some time to try to get us back on track. As due to global COVID-19 situation, that makes the situation a lot difficult. Our site visits were not allowed during these times. And we had to make a lot of assumptions on the data based on our understanding in our previous visits due to limitations. And all of our group meetings had to be held online for social distancing.
All right, so now I'm going to go into a little bit of Rite Screen's current state. I'm going to talk about their manufacturing process, cell layout, and a little bit of our data that we collected. So to start off, their current manufacturing process is about a 7-step process. It starts with lineal material being brought into the working cell. The first associate will then cut it down to size using a razor gauge system. Orders come in using a computer system so they know how long to make each side. That same associate will then take the jam, so that is the upper right, left and right hand side of the frame, and they'll punch holes for hardware installation later on in the cell. Once that is done, that associate will pass the header sill and then the 2 jams over the table to the next associate, where they will then assemble the frame using a friction fit corner key system. From there, the associate will pick one of the 2 screening tables for mesh to be inserted into the frame. Once that is done, it goes through a quality inspection, and then plungers are inserted. This is what helps keep the frame inside of the window. From there, the completed frames will go to the shipping department. So this is a very basic overview layout of cell 1. You can see the 5 black circles represent the 5 associates in the cell. Laid out are also the 5 different steps that are done here. You can see the 2 different screening tables that they can choose from. Then this is a very basic overview of all 6 cells. Raw material enters the left side of the cell and completed frames exit the right. You can see that the first 4 cells are all very set up similarly. These cells run very similar product line. Rite Screen does about 15 different window screen types, and then so each cell kind of produces their own. Cells 5 and 6 are set up differently because of the different product type that they run. And then on the right-hand side, you can see the 3 different hardware stations. Each hardware station can take the workforce from 1 to 3 different cells at a time. So this here is a very basic value stream map that we created from our time studies that we did. You can see that step 4, the inserting mesh, is that screening station again. That is our bottleneck of the operation with an average cycle time around 1.5 minutes. This time started when the assembled frame was picked up by the operator and then ended once the mesh was inserted into the frame and passed on to the quality station. So with the time study data that we collected, we did a very basic, simple simulation model of an 8-hour day with no breaks being taken. From there, we determined that 684 screens could be produced in one cell within that 8-hour day, with an average rate time to insert the mesh for around 58 minutes. You can see in that picture on the right, completed frames start to build up because the bottleneck, again, is that screening station. We also did a utilization calculation for each of the workers. You can see that the very first half of the cell, those workers are being utilized a lot more than the back half. This is because, again, that insert mesh screening station is the bottleneck of the operation. So the back half isn't being as utilized as much as the front half. That's because they're always waiting for units to be finished so that they can inspect the quality and then insert the hardware. So the utilization calculation is kind of the work that they're capable of doing versus the work that they actually are doing in that average working day. So this here is kind of a graph of the production outputs from December of 2019. This is their daily averages for like 8-hour days they were running during that month. They had a daily goal of about 900 units per cell. You can see that their actual daily average ranged from 300 screens to 700 screens. So well below what their goal was with cell 3 productivity percentage, only around 33%. So this is kind of where we focused our project to kind of drive what we were doing. So next we're going to kind of go over the screening process, the current process that they do, and the table that they are using. So here as I start the video, you're going to see two different assembly workers. The worker on the right-hand side is a newer associate who is still kind of learning the way of the screening table versus the worker on the left-hand side is a little bit more experienced. It takes about 6 weeks for each associate to get fully trained at the screening table. So this operation starts with the associate grabbing that assembled frame and placing it on the work table. From here, they'll have to readjust and position the magnets to lock down the frame onto the table. Each different frame size, they will have to move and replace each magnet. So this is kind of the very time-consuming part of this operation. Next, they will pick one of the 4 different size mesh and different opacancy based on the order they are working on and roll that over the frame. Next, they will spline the frame, so they'll insert the spline around the crevice and the parameter of the frame. This is the very manual process here. They have to exert a lot of force in order to get that spline in the groove. They will then use the backside of that same tooling and cut off any excess mesh that is present and deliver that final screen product to the quality inspector. So here again is the current table that they're using, that magnetic lockdown system for any custom screen sizes. On the very kind of right side there, you can see the holder stand for the 4 different screen rolls. This is that very manual process, very labor intensive. One table can produce up to 427 screens within that 8-hour day. It has a max screen size of 47 inches by 96 inches and a minimum screen size of 8 inches by 10 inches. Some of the ergonomic observations and concerns that we've noticed while watching the screening station is that many employees showed a lot of fatigue and they restricted some of their range of motion. When, say, splining the screen, they would bend over rather than extend their arms throughout the day because they were becoming more fatigued. We noticed a lot of employees modifying different tools and equipments and some of the workstations they were working at. Like some of the shorter associates were standing on boxes because they were not able to reach that top of the work table. They couldn't bend over and reach the top. They had to stand on a box, which is kind of unsafe. This is a very high employee turnover station. And throughout the day, their quality rejection rate increases significantly as the employees get a little more tired. Again, we've noticed that this is definitely the bottleneck of the production cell. And when talking to employees, this is the station that has the most problems and easiest way to improve. Some easy benefits of introducing better ergonomics into the workplace is it can reduce their costs, improves productivity and quality, as long with employee engagement, and it can also create a better safety culture. So next, Trevor's kind of going to go over that in the recommendations.
All right, I'm going to go ahead and jump into our proposed alternatives. So first, our first alternative is a custom adjustable table that we had designed ourselves. The table itself is adjustable both with its height and table angle. The height is adjustable by an electric motor, and that adjusts at 1 foot per second, as well as a range of 24 to 48 inches. The table angle is adjustable manually by the far right lever, as you can see in the top left picture. The employee would take that lever, pull up on it, and on the back side there is a slot system. And then when they are done, when they're ready and have selected the notch corresponding to the angle that they want, they would then lower it down into that lock. The tabletop itself has ridges cut out throughout it, and this is to support the lockdown key system that we will implement. The bottom left hand corner of the table has a stationary V locator that all screens will be placed initially when being jigged onto the tabletop. The sliding lockdown key will then slide to the other corner. And right now only one is pictured, but if more are necessary, they can easily put more onto the railing system. Once that other V locator is on that outer corner, there is a locking screw system where they just twist it and it would lock to the rail itself there. We expect that this lockdown key system would allow for minimal turnover time, as right now they're using magnets that don't have that strong of a pull and tend to move around a lot throughout the screening operation, especially when they're splining. And this, we have noticed, definitely increases the cycle time by quite a substantial amount. So we anticipate that by having this new jigging system, they're going to be able to reach their goal of about 60-second cycle times, and this would be able to produce about 480 screens per every 8 hours worked. Our current table, we're estimating that the max size screen that they're going to be able to accommodate for would be a 42 by 91 inch, and then on the lower side for their minimum size would be an 8 by 10 inch. Alternative 2 is a fully automated, and we actually reached out to Spadix and got a quote. So as you can see in the video here, the only employee engagement that is necessary is for the employee to place the actual screen into the machine. Once the machine has the screen, it will then automatically detect the size and then clamp the screen down. Once it is clamped, it will perform the splining operation and then trim the outer mesh or the excess mesh on the outside. This machine also has 4 screen roll holders, so multiple different types of mesh can be readily available. So that doesn't need to be switched out as well. This process would be roughly a 30 to 40 second cycle time, depending upon the employee's ability to get new screens onto the table. And an estimated 720 screens would be the production capacity in an 8-hour shift for this. The downside with this fully automated machine is that the maximum size drops to a little bit to a 38 by 80 inch screen, and then the minimum size is constrained a little bit to a 10 by 12 inch screen. Now, to compare these two with the current design that is on the floor today, we use 6 different factors. The first would be the operator skill level that is required, the ergonomic efficiency of each workstation, the cost, the production capacity of each workstation, and then the maximum screen size along with the minimum screen size. And you can see that the screen sizes listed right now are the maximum and minimum screen sizes that they work with in their custom department. So for the current design, it's important to note that the operator skill level that is required is very high, and the ergonomic efficiency currently has been listed as very low. And that has been seen, as Dani earlier showed, that the pictures showing the employees excessively reaching over the tables to hyperextend their arms for the splining operation. You see the employees putting their arms above a 90-degree angle and putting extreme stress on their shoulders as well as their elbows. So obviously it's very evident that the ergonomic efficiency is very low with this current design. Because of the magnets and the excessive turnover time in between each screen and during the screening process, the screens per hour from our time studies were only 42 screens per hour based off of that 84-second cycle time. There are the max and min screens listed, and we noted that this only meets about half of our required factors that we're comparing these two with. Alternative one, it is important to note that the operator skill level bumps up to a rough medium level, and then the ergonomic efficiency also bumps up significantly. This table would come with an estimated $1,000 cost to make and implement per table, but with the new lockdown key system, we estimate that the turnover in between each screen, along with the fidgeting of the magnets, would significantly decrease, allowing for more screens to be made per hour, and their goal would definitely be met around 60 screens per hour. A constraint with the max screen size is a little bit with only 42 by 91 inch screen size, and then the minimum would be an 8 by 10, so that would definitely be maintained there. We concluded that this met 4 of the 6 factors. For alternative 2, since there is not much employee engagement besides the initial placement of the screen into the machine, the operator skill level remains low, along with the ergonomic efficiency being very high because they do not have to stress their shoulders or anything during the splining operation as the machine does it for them. A big downside with this alternative is that the estimated cost from the quote that we got from SpedX was $121,000 per table. The screens per hour was definitely greater than any of the other options at around 90 screens per table or per machine. It was up to 90 screens, and this was a rough cycle time of in between 30 and 40 seconds. The max and min screen sizes were constrained to 38 by 80, and then for the min was 10 by 14. So that was negative to also point out, because it cannot accommodate the outer range of the min and max screen sizes, that these screen sizes would have to be done on a separate table. Concluding that this met only half of the needs as well, we go into a simple return on investment based off of the costs. So we used a simple $2.50 profit from each screen, and this was based off of industry standard of about 10% profit. And then we took the current time study data that we had for the current table and then ran that at 100% efficiency to get 342 screens per table, not per cell. And then we also did the same with alternative 1 and 2, and that's 480 and 720 there. We calculated the profits based off of the $2.50 profit margin between each screen. We got an $855 profit for the current table. We took the difference between the profits from alternative 1 and alternative 2, and we used these to calculate our return of investment. We, as you can see, for alternative 1, the return of investment is only 3 days per table, so fairly fast. And then alternative 2, because it is so costly, the return of investment for the fully automated table was 128 days per machine. So with all of this data and all of these comparisons, we would back alternative 1. And as you can see in the video here that I'm about to play to the left, this demonstrates the adjustability of the table, how it moves, and then also the lockdown key system. So the initial cost to implement all 12 throughout the 6 assembly cells would be about roughly $12,000. There would be about 2-week turnaround for the return of investment on this, so fairly fast there. The lockdown key system, like I had mentioned earlier, would greatly reduce the turnover times between switching out screens, as well as reduce the finicking with the magnets during the screening and splining operation. Because the turnover times are reduced, the cycle times are also reduced. And because the cycle times are reduced, we can expect increased production capacity and better worker utilization both on the front and back ends of the assembly lines. Because this screen is so adjustable, it comes with a lot of ergonomic improvements. Additionally, some of these ergonomic improvements would be to reduce worker fatigue throughout the day. Since this operation is solely standing, the worker gets fatigued throughout the day and then can adjust the height so they aren't constantly bending over and stressing their back and or shoulders and upper body. This would also eliminate upper body stress, as we had said, as you can adjust the angle of the work table. So if the work table, if it's a bigger screen, you could bring it up so you don't have to stretch so far to reach the top. With the elimination of worker fatigue and the upper body stress, we expect a decreased potential for injuries in the future. This is a big thing to note because if you look to the right, you can see that from the chart, from the OSHA chart, you can see that the workers' claims that have been filed, arm and shoulder injuries, which are most relevant to the screening operation, are in the upper tier of the most costly injuries. So arm and shoulder injuries average around $45,000, which is over three times the amount it would cost to implement the alternative one tables. With the additional adjustability of the workstation, we expect that we can also push a new screening incentive program. So the current screening incentive program that they have right now is based off of productivity, and that is solely on a weekly basis. And the problem with this that we see is that because there's data metric systems and the ways they gather their data isn't necessarily accurate as we would think from the ways they don't have computer systems throughout their warehouse. We see potential for mistakes in assuming the productivity of each individual employee. So we would push a screening incentive program that would be off of a time base with the company. So that would encourage employees to stick with the company longer for longer wages. And we hope that the adjustability of the workstation would also help improve employee engagement and comfortability within the workstation itself. Additional ergonomic suggestions that would be simple and wouldn't cost a lot of money would be simply changing working positions frequently. So right now they don't really rotate anybody, and this would be done by cross-training the employees. So the screening associates right now stay and work straight 8 hours. They do get their regular scheduled shifts or shift breaks. So they have 2 10-minute breaks and then a 30-minute lunch that isn't included into their 8-hour workday. But we feel like more breaks would be very beneficial. So by cross-training the employees, we could have the screening employees maybe move over to the quality station where it isn't as physically demanding and take a break. And then this would also be pushed to pace work appropriately. So by teaching proper standard operating procedures and eliminating extreme bending, stretching, and twisting, and showing them that it's all right to work at the same pace and not rush yourselves throughout the day just to meet. It's important to gain consistent cycle times so they're doing everything properly and not stressing themselves more than they need to. So this, we feel, would be simple improvements that would greatly increase the worker fatigue, greatly reduce the worker fatigue throughout the day, as well as the workers' attitudes on their operations. Some simple purchases that could be made to also benefit the workstation would be anti-fatigue mats, and this not only for the screening operation, but this would be for all operations, because the anti-fatigue mats that they do have now. Some are all right, but a lot of them are very worn out. So it's basically just like kind of like a rug on the ground. There isn't really much support or anything to reduce the fatigue or the stress on the muscles when they're standing. Like I said before, this is all operations that they do. They have to stand the entirety of the day. So it's very strenuous on their leg muscles, and they can get very tired very fast. So by having good anti-fatigue mats, and they're not very expensive, you can greatly increase the worker attitude, along with reducing fatigue throughout the day. Another thing to note is the lighting within the facility. The lighting is all right in a lot of areas, but in some, it does get kind of dim. And the screening operation being a very tedious operation that it is, it requires a lot of focus to where they're putting, especially the splining and how it's putting into the groove. So by having simple clamp-on lights to the workstations, this would take any chance of them being stressed by the vision aspect throughout the operation. This would take all stress off of their eyes and or mental stability throughout that. First, we went over the company background. Andrew also went over the project objectives. And then Dani jumped into our current state and elaborated on the manufacturing processes that we currently have at Rite Screen, and then the current production numbers they're seeing. And the production numbers that you saw were from the month of December, as she noted. We then jumped into the current bottleneck that we see and have noticed from taking the time studies, and that is the screening process. We went over the standard operating procedures for that, and then with the video, you were able to see that it is very ergonomically inefficient, and we listed the ergonomic limitations of the table as well. And then we proposed a couple alternatives. Alternative one being the fully adjustable table that we had designed. It was both cost effective, and it was also had the additional key lockdown system. And then we also proposed alternative two, which is a fully automated system. And this came with a very hefty price tag. When we compared the two, we found that even though the fully automated may have a faster time or cycle time and reduce the fatigue or the ergonomic aspect greatly, we found that the cost was not worth it. The ROI for those was 128 days. So we concluded that alternative one would be our recommended option to go with. Alternative one, because of its adjustability, along with the V-clamping system to secure each screen as it came in. That would in turn reduce the turnover times after, along with during the splining operation too. And then we also listed additional ergonomic fixes that they could do, such as switching employees around or cross-training, and then just reinforcing the standard operating procedures that they have, or maybe touching up on them a bit, and then also putting in a different screening incentive program. And then finally, we went over just the additional purchases that could be made to additionally benefit the workstation. Are there any questions?
Yeah, you said alternative one was the one that you were going with. So what kind of reduction in the bottlenecking, you made a comment about the bottlenecking right up front. What kind of reduction in the bottleneck would that alternative one do?
So their goal right now is to reach a cycle time of 60 seconds. And what we found is that when we took the time studies, most of their time during that cycle time, and it wasn't even just changing the screens out, it was during the actual screening process itself that the magnets would move, and that it was very inconsistent. They had several magnets on the table, and then they would use different magnets on both sides of the screens. And while they were putting such an immense amount of force during splining, that they would consistently move. So they would have to stop, readjust the magnets, and this would add an immense amount of time onto the actual cycle time. So by the new alternative and how it locks down onto the ridges that are cut out, we anticipate that this would greatly reduce the turnover time.
Okay, so did you have a chance to do enough time studies to figure out what if that would eliminate the bottleneck completely, or if you'd still have a bottleneck there?
We anticipate a smaller bottleneck just because of how quick the first few operations are. It's still going to be the bottleneck unless you get into that more fully automated system or even additional screeners in the cell.
Okay. Go ahead.
By having the 2 screening stations they currently have, we estimate that they can reach about, well, with the current they could reach 684 screens, but with the new station that they have, we estimate they could reach about 900, which is above what one automation or automated unit can do. The one automated unit, and we would anticipate that they wouldn't have more than one in each cell because they are so expensive and they are pretty big, so they take up a lot of space. So we would anticipate they would only have one. Well, a fully automated unit only has 720 that can kick out, and that's at 100% capacity with the operator putting the screens in when they should and not any time in between. So with the two, with having the 2 tables and really knocking down that turnover time, we see that with the simulation that we did, we see that the numbers actually are quite a bit higher than just one automation unit that they would buy.
Okay, so the design with the slots, the table with the slots, and is that something that's on the market out there that you can purchase?
Yeah, so the tabletop itself would have to be machined, and that's a 2-part system. So we're using very rigid plastic, almost like we're using HDFE plastic, and it's kind of like the stuff you'd use on decks. So it's very rigid, but we wanted rigid plastic so it didn't wear throughout the time, and it's also it's a lot more light than the material they're using now. But the clamps, there are clamps out on the market that would be suitable for sliding down up and down the rails, but there were not many clamps that I found that had the actual V locators put it out. But those would be very easily welded on, or per se. And then the V clamp was also the V locator, the stationary one on the bottom left-hand side. You can buy those. So there would be some additional requirements for making that happen, but I feel like that wouldn't be too excessive. They have a welding unit in-house, so they'd be able to weld on a V clamp or a V locator to that. So I don't see it being too big of a problem.
So they could buy the table and they could fabricate the rest of it if they had to.
Yep.
Yes.
Okay. So how receptive do you think they are going to be to alternative 1?
I would say they'll definitely give it a look. I know they've kind of been fidgeting with the screening operation for a long time, but I hope they're able to see that this is actually a very viable option that we see with eliminating the turnover time. With the new clamping system, I do see that the cycle times would be more consistent and also improved. So,
along with all of the ergonomic benefits of a new table to adjust the table per height of the associate versus just what it is now and it's not adjustable at all.
Would the alternative one, because you made some comment about the quality coming out of there too, is not very good. They do a lot of rejects. Would the alternative 1 eliminate some of those rejects?
Yeah, so along with like some of the additional recommendations that we made, because workers get fatigued, they saw more rejects towards the end of the working day. So being able to cross-train the employees and having more than their handful of screeners that they have right now. And just because that is such a highly trained position, that could also help with the reject rate.
I would also say with the stationary V locator in the bottom left side of the screening table and the consistent ways they would be putting and jigging the actual screen onto the table with more consistent force, obviously, that they wouldn't necessarily have so varied quality throughout the process. I feel like having more consistent forces holding the screen on would definitely increase the quality when they're splining and putting this mesh on.
Okay. Good presentation. Good ideas, good alternatives, and I think it's probably something they should, if they aren't going to consider, they should consider at least some of it. They have the option with the 6 cells to just experiment with it in one cell and see what the true outcomes are. I mean, that would be an advantage they have, and it's probably not going to cost that much to do a test or a sample in one of their cells and see how it works out.
Yeah.
So, good. I don't